Hello everyone. In this session, let's learn how to construct a DFA to accept binary strings ending with 00. We know that DFA is a mathematical model to accept regular languages. Let this DFA be represented with Q, the states of the automata, and sigma, the input symbols. Here in this problem, it is 0, 1, and let Q naught represent the initial state and F represent the final state. So here, this DFA has to accept the strings ending with 00. So now let's construct the string, construct the automata with initial state Q naught. On reading a 0, it can make a transition to another state. And again, on reading the second 0, it can make a transition to Q2. Thus, this automata can be made to accept the string 0, 0. Let's mark this Q2 as final state. So this automata will accept the binary string 0, 0. Now, in this question, the strings that ends with, in that case, it can begin with any value 0 or 1 and followed by any type of values, but finally it should end with 0, 0. So, in order to accept those strings, let us look at the possibilities of getting the numbers in every state. So in the initial state, if this automata reads a 1, then it need not make a transition to another state, because anyhow finally it has to go with 0, 0 to end it in Q2. So let's make the transition on 1 as a self loop, so that any number of ones can be read in the beginning, but it should ensure that it is followed by 2 zeros. Now, after reading a 0, suppose if it encounters a 1, like numbers like 101, then in that case, again, the machine has to ensure that it reads 2 zeros and only ends. Therefore, if it reads a 1 here, it should not be a self loop, but it can go to the previous state. If it goes to the previous state, then there is a chance for reading 0 and again 0. So there is a chance for the machine to read 0 and go to Q1, again 0 to go to Q2. Thus, any number that is beginning with 1 followed by 0 and 1s and any number of 0 ones will ensure that it has to read 2 zeros before it ends at the final state Q2. Now, in the state Q2, suppose if it reads a number 0, then it can be given as a self loop, because this any number of zeros has made finally as already 2 zeros are read. If it reads one more 0, it is going to end with 3 zeros or 4 zeros and so on. Therefore, in Q2, it can read any zeros, but the ending with 2 zeros is not affected. But if it reads a 1, then this again has to end with 0, 0. Therefore, if it reads a 1 in this place, then it has to go to Q naught to ensure that after going to Q naught, it has to read two zeros. Only then strings like, for example, if the number is, if the word is 1, 0, 1, 0, 1, then on reading 1, it will be in Q naught itself. After reading the second 0, it will go to Q1. Then on reading 1, it will come back to Q naught. Then on reading 0, it will go to Q1. And again on reading 0 it goes to Q1, and again on reading 1 it will come to Q naught. But after reading this one, only if it reads two zeros. Whenever it reads a 1, it comes back to Q naught in order to ensure that after that it has to read two zeros. From Q naught it has to read 0 to Q1 and again 0 to Q2. Only then this this sort of inputs will be accepted. Otherwise, even if we have a string of type 1, 0, 0, 0, any number of zeros, then after reading two zeros, it is going to remain in state Q2 and any number of zeros will be in Q2 itself. So these strings are also going to be accepted. Thus, this is how we construct the automata which ends with which accepts the binary strings that ends with 0, 0. So the transitions are given by on Q naught, on reading a 0, it goes to Q1, and on reading a 1, it remains in Q naught itself. And then from Q1, on reading 0, it goes to Q2 to the final state. And on Q1, if it reads a 1, it comes back to Q naught. And then in Q2, it can read any number of zeros because already two zeros are read. It will make only as three zeros, four zeros. And in Q2, if it reads a 1, then it has to come back to initial state so that it will ensure that two more zeros are read and before accepting the binary string. So this is how we construct the uh, deterministic finite automata to accept the binary strings ending with 0, 0. Thank you.